Okay, in question 18 we have a stunt driver. He leaves an incline with a speed of 35 meters per second at an angle of 32 meters at 32 meters above the ground, and so what we need to figure out again is what the Vx and the Vy is, because that's what we're asked here, is what are the vehicle's vertical and horizontal components. So I think we're pretty used to this by now. Vx is equal to 35 meters per second multiplied by the cosine of 28. Vy is equal to 35 meters per second times the sine of 28. When we do those, we get Vx is equal to 30.9, and we get Vy is equal to 16.4. Just like that. Alright, now the next one is quite a bit more challenging, and I normally wouldn't have you do this type of question because it involves a quadratic formula, but let's just go for it and see how we do. We can use this formula: d is equal to v naught t plus 1/2 a t squared. If you notice, we want t, but it's in two places, and so that's why we need the quadratic formula. When we set this up, we get negative 52 is equal to v naught. Remember, this is v naught in the y direction, so the 16.4 is used here, and 1/2 a is 9.8, and t is squared. We need some signs in here because the negative sign on 9.8 tells us that it's down, the negative sign on 52 tells us that it's down. Rearrangement gives us 0 is equal to negative 4.9 t squared plus 16.4 t plus 52. This is set up nicely for the quadratic formula, so negative 16.4 plus or minus the square root. Let's fix that. Plus or minus the square root of 16.4 squared minus 4 times a, which is the negative 4.9, times c, which is the 52, all over 2 times negative 4.9. When we work this out, you will get two answers. You'll get 5.3 seconds or negative 2.0 seconds. Obviously only one of these. The 5.3 seconds makes sense. So that's our answer. For the range is the x direction, so that's Vx times t. For this we're going to get the 30.9 then. We return to the Vx usage there, multiplied by the 5.3 seconds that it's in the air, and we get 165 meters total distance.